स्वागत है जी आप सभी का हमारी एक और नई वीडियो के अंदर। तो कैसे हो आप सभी लोग? आई होप सभी अच्छे होंगे। तो आज करेंगे चैप्टर केमिकल इफेक्ट ऑफ इलेक्ट्रिक करंट। योर एल्डर्स माइट हैव continued you against touching an electrical appliance with wet hands, but do you know why it is dangerous to touch an electrical appliance with wet hands? We have learnt earlier that the material which allow electric current to pass through them are good conductor of electricity. On the other hand, material which do not allow electric current to pass through them easily are poor conductor of electricity. In class 6th, we made a tester to test whether particular materials allow the electric current to pass through it or not. Do you recall how the tester helped us in deciding that? We find that material such as copper and aluminum conduct electricity, whereas materials such as rubber, plastic, and wood do not conduct electricity. However, so far we have used our tester to test material which were in solid state. But what about liquids? Do liquids also conduct electricity? Let us find out. Haley and Bhujo want to remind you that one should not experiment with the electric supply from the mains or a generator or an inverter. Use only electric cells for all the activities suggested here. Activity 11.1. Do liquids conduct electricity? To test whether a liquid allow electric current to pass through it or not, we can use the same tester. However, replace the cell by a battery also. Before using the tester, we should check whether it is working or not. Activity 11.1. Join the free ends of the tester together for a moment. This completes the circuit of the tester and bulb should glow. However, if the bulb does not glow, it means that the tester is not working. Can you think of the possible reasons? It is possible that the connections are loose, or the bulb is fused, or your cell are used up. Check that all the connections are tight. If they are, then replace the bulb with a bulb. Now test if the tester is working or not. If it is still not working, then replace the cell with fresh cells. Now that our tester is working, let us use it to test the various liquids. Activity 11.2. Collect a few small plastic or rubber caps of discarded bottles and clean them. Pour 1 teaspoon of lemon juice and vinegar in one cap. Bring your tester over this cap. At the end of the tester, dip into lemon juice or vinegar as shown in figure 11.2. Take care that the ends are not more than 1 centimeter apart, but at the same time do not touch each other. Does the bulb of the tester glow? Does lemon juice or vinegar conduct electricity? How would you classify lemon juice or vinegar, a good conductor or a poor conductor? When the liquid between the two ends of the tester allows the electric current pass, the circuit of the tester becomes complete. The current flows in the circuit and the bulb glows. When the liquid does not allow the electric current to pass, the circuit of the tester is not complete and the bulb does not glow. In some situations, even though the liquid is conducting, the bulb may not glow. If it may have happened in activity 11.2, what can be the reason? Do you remember why the bulb glow when the electric current passes through it? Due to heating effect of electric, the filament of the bulb get heated to a high temperature and it start glowing. However, if the current through a circuit is too weak, the filament does not get heated sufficiently and it does not glow. And why is the current is the in the circuit weak. Well, through a material may conduct electricity, it may not conduct it as easily as a metal. As a result, the circuit of the tester may be complete, and yet the current through it may be too weak to make the bulb glow. Can we make another tester which can detect a weak current? We can use another effect of an electric current to make another kind of tester. Do you recall that electric current produces a magnetic effect? What happens to a compass needle kept nearby when current flows in a wire? Even if the current is small, the deflection of the magnetic needle can be seen. Can we make a tester using the magnetic effect of currents? Let us find out in activity 11.3. You may use an LED figure 11.3 in place of an electric bulb in the tester of figure 11.2. LED glows even when a weak electric current flows through it. There are two wires called LEDs connected to an LED. One LED is slightly longer than the other. Remember that while connecting to a circuit, the longer LED is always connected to the positive terminal of the battery, and the shorter LED is connected to the negative terminal of the battery. ये LED बस है. Activity 11.3. Take the tray from inside a discard matchbox. Wrap an electric wire a few times around the tray. Place a small compass needle inside it. Now connect one free end of the wire to the terminal of the battery. Leave the other end free. Take another piece of wire and connect it to the other terminal of the battery. Figure 11.4. Join the free end of the two wire momentarily. The compass needle should show deflection. Your tester with two free end of the wire is ready. Now repeat activity 11.2 using this tester. Do you find a deflection in the compass needle the moment you dip the free end of the tester is lemon juice? Take out the end of the tester from the lemon juice, dip them in water, and then wipe them dry. Repeat the activity with other liquids such as tap water, vegetable oil, milk, honey. In each case, observe whether the magnetic needle shows deflection or not. Record your observations in 11.1. Table 11.1. Good or poor conducting liquids. तो ये एक्टिविटी फिल करनी है. तो लेमन जूस कंपास निडल शोज डिफ्लेक्शन, यस. विनेगर, यस. टैप वाटर, यस. वेजिटेबल ऑयल नहीं करता. मिल्क, यस. हनी, नो. लेमन जूस गुड कंडक्टर, विनेगर गुड कंडक्टर, टैप वाटर गुड कंडक्टर, वेजिटेबल ऑयल बैड कंडक्टर, मिल्क गुड कंडक्टर, हनी बैड कंडक्टर. आप इसमें खुद कुछ भी और भी यहाँ पे लिख सकते हो मटेरियल्स. From table 11.1, we find that some liquids are good conductor of electricity and some are poor conductors. When the free end of the tester do not touch each other, there is an air gap between them. Paheli knows that air is poor conductor of electricity, but she has also read that during lighting an electric current passes through air. She wonders if air is indeed a poor conductor under all conditions. This makes Bujo ask whether other materials classified as poor conductor also allow electricity to pass under certain conditions. Actually, under certain conditions most material can conduct. That is why it is preferable to classify materials as good conductor and poor conductor instead of classifying as conductors and insulators. We have tested the conduction of electricity through tap water. Let us now test the conduction of electricity through distilled water. Activity 11.4. Take about 2 teaspoonfuls of distilled water in a clean and dry plastic or rubber cap of a bottle. use the tester to test whether distilled water conducts electricity or not. What do you find? Does distilled water conduct electricity? Now dissolve a pinch of common salt in distilled water. Again test. What do you conclude this time? When salt is dissolved in distilled water, we obtain salt solution. This is an conductor of electricity. The water that we get from sources such as taps, hand pumps, wells, and ponds is not pure. It may contain several salts dissolved in it. Small amount of mineral salt are naturally present in this water is thus a good conductor of electricity. On the other hand, distilled water is free of salts and is a poor conductor. Small amount of mineral salts present naturally in water are beneficial for human health. However, these salts make water a good conductor, so we should never handle electrical appliances with wet hand or while standing on a wet floor. We have found that common salt, when dissolved in distilled water, makes it a good conductor. What are the other substances which, when dissolved in distilled water, make it conducting? Let us find out. Activity 11.5. Take 3 clean plastic or rubber cap of bottle. Pour about 2 teaspoonfuls of distilled water in each of them. Add a few drops of lemon juice or dilute hydrochloric acid to distilled water in one cap. Now in the second cap containing distilled water, add a few drops of base such as caustic soda or potassium iodide. Add bitter sugar of the distilled water in the third cap and dissolve it. Test which solutions conduct electricity and which do not. What results do you obtain? Most liquids that conduct electricity are solution of acid, bases, and salt. When an electric current flows through a conducting solution, does it produce an effect of the solution? 11.2 Chemical effect of electric current. In class 7th, we have learned some effect of electric current. Can you list these effects? What effect does the current produce when it flows through a conducting solution? Let us find out. Activity 11.6. Take out carbon rod carefully from two discard cells. Clean their metal cap with sandpaper. Wrap copper wire around the metal cap of the carbon rod and join them to a battery. We call these two rods electrodes. Pour a cup full of water in a glass plastic bowl. Add a teaspoonful of salt or a few drops of lemon juice to water to make it more conducting. Now immerse the electrodes in this solution. Make sure that the metal cap of the carbon rod are outside of the water. Wait for 3-4 minutes. Observe the electrodes carefully. Do you notice any gas bubbles near the electrodes? Can we call the change taking place in the solution a chemical change? Recall the definition of a chemical change that you learnt in class 7th. In 1800, a British chemist, William Nicholson, 1753 to 1815, had shown that if electrodes were immersed in water and a current was passed, bubbles of oxygen and hydrogen were produced. Oxygen bubbles formed on the electrode connected to the positive terminal of the battery, and hydrogen bubbles formed on the other electrode. The passage of an electric current through a conducting solution causes chemical reaction. As a result, bubbles of the gas may be formed on the electrodes. Deposit of metal may be seen on electrodes. Change of color of solution may occur. The reaction would depend on what solution and electrode are used. These are some of the chemical effects of electric current. Bujo decided to test whether some fruits and vegetables also conduct electricity or not. He cut a potato into two halves and inserted the copper wires of a tester into it. Just then his mother called him and he forgot to take out the wires of the tester. Instead, into the potato. When he came back after half an hour, he noticed that there was a greenish blue spot on the potato around one wire, whereas there were no such spot around the other wire. He was surprised with these observations and along with Paheli repeated this activity many times. They found that it was always the wire connected to the positive terminal which had a greenish blue spot around it. They felt that this discovery was very useful because it could be used for identifying the positive terminal of a cell or a battery concealed in a box. They decided to report their finding to a children's magazine. Remember that Bujo set out to test whether potato conducted electricity or not. What he found was the current produced a chemical effect in the potato. To him, this was very exciting. In fact, that is how science sometimes works. You are looking for something and you discover something else. Many important discoveries have been made in this manner. 11.3 Electroplating. You know that brand new bicycle has shiny handlebar, wheel rims. However, if these are accidentally scratched, the shiny coating comes off, revealing a not so shiny surface beneath. You might have also seen women using ornaments which appear to be made of gold. However, with repeated use, the gold coating wears off, revealing silver or something other metal beneath. In both these cases, a metal has a coating of another metal. Do you wonder how a layer of one metal can be deposited on top of another? Well, let us try doing it ourselves. Activity 11.7. We will need copper sulfate and two copper plates of size around 10 centimeter by 4 centimeter. Take 25 to 50 ml of distilled water in a clean and dry beaker. Dissolve 2 teaspoonfuls of copper sulfate solution in it. Add a few drops of dilute sulfuric acid to copper sulfate solution to make it more conducting. Clean copper plates with sandpaper. Now rinse them with water and dry them. Connect the copper plates to terminals of a battery and immerse them in copper sulfate solution. Allow the current to pass for about 50 minutes. Now remove the electrodes from the solution and look at them carefully. Do you find any difference in any one of them? Do you find a coating over it? What color is the coating? Note down the terminal of the battery with which this electrode is connected. After doing the electroplating activity, Paheli interchanged the electrodes and repeated the activity. What do you think Chief would observe this time? When electric current is passed through the copper sulfate solution, dissociates into copper and sulfate. The free copper get drawn to the electrode connected to the negative terminal of the battery and get deposited on it. But what about the loss of copper from the solution? From the other electrode, a copper plate, an equal amount of copper get dissolved in the solution. Thus the loss of copper from the solution is restored and the process continues. This means that copper get transferred from one electrode to the another. Bhuja could get only one copper plate, so he performed activity 11.7 by connecting a carbon rod in place of the copper plate which has connected to the negative terminal of the battery. He succeeded in obtaining a coating of copper and on carbon rod. The process of depositing a layer of any desired metal on another material by means of electricity is called electroplating. It is one of the most common applications of chemical effect of electric current electing is very useful process. It is widely used in industry for coating metal object with a thin layer of different metal. Figure 11.8. The layer of metal deposited has some desired property which the metal of the object lacks. For example, chromium plating is done on many objects such as car parts, bathtubs, kitchen gas burners, bicycle handlebars, wheel rims, and many other. Chromium has a shiny appearance. It does not corrode. It resists scratches. However, chromium is expensive and it may not be economical to make the whole object out of chromium, so the object is made from a cheaper metal and only a coating of chromium over it is deposited. Jewelry makers electroplate silver and gold on less expensive metals. These ornaments have the appearance of silver and gold but are much less expensive. Tin cans used for storing food are made of electroplating tin onto iron. Tin is less reactive than iron, thus food does not come into contact with iron and it protected from getting spoilt. Iron is used to bridges and automobiles to provide strength. However, iron tends to corrode and rust, so a coating of zinc is deposited on iron to protect it from corrosion and formation of rust. In the electroplating factories, the disposal of the used conducting solution is a major concern. It is a polluting waste and there are specific disposal guidelines to protect the environment. तो यहाँ पे हमारा चैप्टर फिनिश होता है.